On time shifting, that is time delay or time advance. Power will not change and energy also will not change. Both will not change on shifting. Second, on time scaling. On time scaling, that is either compression or expansion. One, power will not change, but energy will be changed. Energy changes. How much the energy changes, I will discuss. I will give a proof. And one more point. Third one, on amplitude scaling. That is amplification or attenuation. Suppose from y of t equal to a times x of t, then power equal to a square times of power of, let us say, x, power of y equal to, and energy of y equal to a square times of energy of x. Okay, y of t, let us say px is power of the signal, x of t, and py is power of this signal, y of t, and ex is energy of the signal, x of t, and ey is energy of the signal, y of t. Okay, so on amplitude scaling, both power and energy will be changed. So I will give proofs for these things. So the first one, on time scaling, let us say y of t equal to, first one is time shifting, x of some t plus a. Okay, suppose if it is a energy signal, I will calculate energy, that equal to energy of y, integral minus infinity plus infinity magnitude of y of t whole square dt. This energy, integral minus infinity plus infinity x of t plus a whole square dt. But we know that energy of the signal, let us say ex, that equal to integral minus infinity plus infinity x of t whole square dt. This we know. So from this, let us say t plus a equal to some tau. Okay, what is dt? That is d tau. And from this, if t equal to minus infinity, what happens? Tau equal to minus infinity plus a equal to minus infinity. If t equal to plus infinity, tau also plus infinity. Change the limits. Tau equal to minus infinity plus infinity. This energy of y and x of tau, and dt is d tau. This one is squared. Okay, so this is same as energy of x of t, because this tau is a dummy variable. It looks like same, the signal. this. Okay, uh, this function ex. So Ey equal to x. Energy will not be changed on time shifting. Power also. Power also will not be changed. Same. Here we get 1 by t. That's it. And what if A is negative? If A is negative, so here if A is negative, the limits also changed. Plus infinity will become minus infinity. Minus infinity will become plus infinity. Tau limits. So tau equal to plus infinity to minus infinity will get, and A into t equal to tau. Here A is negative, so dt equal to minus of d tau by A. So if we change the limits, you have to multiply with minus 1. Here already minus d tau is there, minus minus cancel. So you won't get any negative term at the outside if A is negative also. So Ey is, you can write 1 by Ex by mod A. So Ey is Ex by mod A, because it is energy, right? Energy is a positive value. Okay, next one, the power. What happens? Power will not be changed. Why? Calculate what is, let us say Py. So if let us say t dash integral of minus t dash by 2 to plus t dash by 2 y of t whole square dt. This is power of y of t, but y of t equal to x of at. So suppose x of t has period t, then x of at has, what happens? This is compression. So x of at has period, each time instant gets divided by a, so period also gets divided by a. Okay, this will happen. So this is t dash. Substitute this in this equation. So py equal to 1 by t dash is t by a, integral of minus t by a y plus t by 2a. Y of t is x of at whole square dt. That is a by t, integral of minus t by 2a to t by 2a x of at whole square dt. Let us say at equal to tau, a into dt equal to d tau, and dt equal to 1 by a d tau. Substitute all these things. A by t, tau equal to, so what if t equal to minus t by 2 to a 2a, then tau equal to minus t by 2. Substitute this in the limits, tau limits. Here t equal to minus t by capital T by 2a, a cancel, minus t by 2. And here with small t equal to capital T by 2a, then what happens? Tau value, a gets cancelled, we'll get again t by 2. And x of at is tau, so x of tau whole square dt is d tau by a. Okay, but this a gets cancelled. This is 1 by t, integral tau equal to minus t by 2 to plus t by 2 x of tau whole square d tau. But this is same as px. Okay, this is same as px. So power will not be changed on scaling, but energy will be changed. Okay, next one. Anyway, these amplitude operations you can easily get. Suppose if y of t equal to some a times of x of t, what you get? Energy equal to integral minus infinity plus infinity y square of t. So you will get a square at the outside, integral minus infinity plus infinity x square of t, that is a square into ex. this is Ey. Same Py equal to A square into Py, you will get. Okay, so not that hard. That's it. So I will summarize. If x of t has energy E of energy signal, or x of t has power, say this is x, px if it is power signal. Okay, then y of t equal to x of at plus or minus b multiplied with some constant k. Then what is the power p, py and energy ey. So this is ey, energy of the signal y, ey equal to k square, and on scaling energy will be changed, that is ax by. And what is power? If it is power signal, then an amplitude scaling will get k square, but power will not be changed on time scaling and time shifting. Okay.